Hey guys, welcome back to your fourth Autodesk Eagle tutorial, and we're just going to pick off where we left off last time. And so last time we went and talked about the schematic and how we can actually connect components together, what these little symbols do, the idea of what a net is. So if I click on these lines, each one of the lines has a given net name. Alright, and that's going to help us later on in specifying some of the different parameters we need for the board layout. But this is actually a pretty good schematic we have so far. Now let's go ahead and actually transition to generating the board layout. So we talked about how Eagle has two different stages to it. One is simply designing this view, which is our schematic view, and then the next stage, once you have this whole thing laid out, is to start to create what the board layout looks like. So in order to transition from this schematic window to the board layout window, we need to first click this button up here. This is the generate / switch to board tool. Okay, if I click this, it's first going to prompt me with it's saying that the board file currently does not exist. Do you want to generate it from this schematic? Yes. If this message will only pop up if you have never generated the board file before. Okay. If you already had the board file, it would just simply switch directly to the board file. So if I hit yes, you can see that this is what that physical layout looks like. But if I ever need to switch back and forth with the schematic, I just need to click this button again, and it just sends me back to the schematic. Okay. Now, one thing that's also pretty important to note is that Eagle will maintain any changes that you make from the schematic to the board. Okay, so if you decide, oh, I want to connect, this line to this line, Eagle will automatically update that into your board layout. Alright, so let's go ahead and just start playing around with this. So the first thing we got to cover is what this little orange outline indicates in an Eagle board layout. And this orange outline is indicating what the manufacturer will see as what the outline of your board looks like. So if I were to actually look at some PCBs out there, I'm just going to type in PCB. You can see in the case of a board like this, the outline is this outermost edge where the cut is done on the board to size it down. You can have circular boards, you can have these odd shaped boards, but the outline that we indicate in orange is going to be what the final cut of the board will look like. So when I start to move these components over from here to, let's say, over here, I don't need my board cut out to be this big. This is when I can start to actually resize this down. So you can see if I use the move tool and start to grab an edge, I can slowly start to bring in this down. So this orange layer is known as the dimension layer. If you have anything in the dimension layer, that will be something that will be cut out whenever the manufacturing process is whenever you send your board to the board house, it will cut out that orange outline. Alright, so before, when we were in the schematic, we did talk about the layer settings, but we didn't say it was as important as it is in the board layout. Now if I click on the layer settings, there's a whole bunch of different options here, and we're going to be using all of these throughout our little tutorial series. But you can see that I have the ability to change the visibility of some of these options if I ever need to remove them. But that's just one thing we can do. the next thing I want to cover is just actually going through the process of starting to do the routing. Pretty much all of these options are the same from the actual schematic side. Okay, so we're just going to start to lay out, start moving the components around so that they are kind of right next to each other. Now you'll notice that as I move this component, you'll see that there are these wires that just follow the part, and these are known as air wires. Okay, air wires indicate what that pin needs to be connected to at some point. So when I go about optimizing for the position that I need the component to be, I'll try my best to put it next to where it needs to go. So you can see that this little pin right here needs to connect to pin 3. So putting it pretty nearby is going to make it easier to route to. So I see that I also have this second LED here. And I could kind of do the same thing. And then I'll do the same thing over here. Then I'll have another LED over here. And, that's a pretty good layout so far. Everything has direct connections to it. And the reason that, these direct connections are so helpful is because now if I switch over to start, performing the routing, and the way we do it, is one way we can do it is to manually route our board. And to do that, we're going to use the route tool over here. I'm going to click that. And if I just go ahead and click from point to point, you'll see that I create this small trace. Now, when figuring out what width you need your trace to be, so like you can see up here, there's an option for selecting, how wide I want my trace to be. Now, the unit of measure that we work out of most commonly with designing PCBs is the unit of mil. So mil is not a millimeter. You can see that millimeter and mil are two different things. So mil represents 1,000th of an inch. Okay, so currently I have the graph indicator set to increment at 50 thousandths of an inch. All right. Now, when I change my trace width, this is 6 thousandths of an inch. The larger that I make this, I can make this like 24, so this is 24 thousandths. You can see that the trace got a lot bigger. So, the question that you might be asking is, how do I figure out what trace width to use for my application? And the simple answer to that is, you need to first figure out how much current will be passing through that line. So if, in our case, I have this Arduino is going to output a 5-volt signal across this, 10K ohm resistor connected to here, and then that just connects back to ground. This is what it boils down to is just a very simple V equals IR, and from that you can figure out what that current going through it is. Once you have the current and you know how much it is, you could then move on to actually using a graph to show us. So if I type in PCB trace with current, you can see that I can look at some charts like this to give me a pretty good reference. Okay, so this is saying that it recommends a trace width for 1 ounce copper core. Okay, so this 1 ounce is a factor that we will have to specify to the manufacturer whenever we go to actually order our boards. By default, you're going to have about 1 ounce copper for standard sized boards. Okay, and you could see that for 1 ounce copper boards, this if the current that you calculated is 1 amp, you need to use a trace width of about 10 mil. Okay, and correspondingly, as you move down here, the supported current is listed there. Okay, so that's how you'd go about actually selecting the width that you would need for these traces you create. Alright, and so this is really, let's just go ahead and start to finish this up. Like that, like that. I'm just going to go ahead and bring that volume down. and you can see that I've connected everything kind of together, and I'm gonna finish it up. Just connecting that, and at this point I'm really done. But there are a couple things I want to show you that can really simplify your life. And a big one will be, you can see that, a lot of these devices are using, this device, the Arduino itself, it has a bunch of grounds. This LED has a ground, this LED has a ground. And, instead of actually creating a little trace for each one of them, one thing we can actually do is to use what's known as a ground plane or a ground pour. So if you ever need to rip up a trace, you can use this little, it looks exactly like the route tool except it has an X on it. And then you can just click on the traces you want to get rid of. In our case, I'm just going to get rid of these ground traces. Let me show you a little handy trick that can save you a lot of time. So I can see I can actually make this smaller too. Now, to actually start creating this ground pour, we're first going to need to go to the Polygon Tool off on the side. If I click that, I then need to specify which layer I want to do this on. Now, for double-sided PCBs, which is probably the most common type of PCB, you're going to have a top layer and a bottom layer. Now you see these red, you see how this trace is red? This indicates that the trace is located on the top side of your board. So your board will have a top side and a bottom side. Alright, so any traces that are on the top side are going to be red, and any traces on the bottom side are going to be blue. At least by default in Eagle. You can modify this, or if you decide to create more than you want to use more than just 2 layers, you can create 3, 4, 5, 6, up to I think about 12 layers, and they all can have different colors. But for the purposes of our tutorial, we're just going to stick to double-sided PCB, so red and blue are going to be the colors we talk about. So we need to specify what side we want this port to go on, and then we're just going to start to create this outline around our whole board. And I'm just going to keep right clicking until I get this option here. You can manually just click this right angle tool. And I'm just going to go ahead and start to come around up until I can complete this little line here. And you're going to see that if you do it properly, if it's still a solid line, that means you did not connect it together. But if you get a dotted line, that means you were able to make a full connection back. And now if I go ahead and hit the rename tool, I can actually name this polygon whatever I'd like. So currently it has the name n_4, but what I'll do instead is actually call it GND, which is, that signal that I'm trying to connect all of these together. And if I hit OK, you see nothing happens. And the reason that this happens is because I need to refresh my view. And the way you do that is by using this tool right here called the rat's nest tool. Okay, rat's nest is just meant to update, so we talked about this air wire, and I may bring the air wire from, let's say that I take, before I go ahead and hit the rat's nest, let's say I take this LED, and it's supposed to point me to the location that's closest to completing it, like this, that's satisfying this. And I may move it all the way over here, and then if the only way I can make that connection is by ground, I will have all of these points that they need to connect back to. But at some times, and this is if this doesn't make sense, it's going to make sense kind of later, that you'll see that as I hit rat's nest, some of these lines will update. And I think for the most part, lines won't update, except for the fact that they will update because I had the ground plane here, so all of those lines are now disappeared. Now what the ground plane did was it simply opened up a section of the little copper pad that was there and connected it to this large copper plane that now sits on the back of this, that sits on the top of this board. And all you can see all of this. You can see in the regions where the copper plane is not supposed to connect to a trace, there is this distinct outline surrounding it. So that's how the copper does not short with any of the traces that aren't supposed to be connected to it. So anything that's not supposed to be connected to it, like you can see this SCL and all of these other pins have this black outline to it that doesn't allow the copper to get into the trace. But where it does need to, you can see that it actually opens up into the pad for it to be connected. So this is one way you can, simplify your designs. And if, ground is something that most devices are going to have, and this is one way you can just make connections without having to worry about actually physically making that connection with traces. All right. So that is pretty much the actual routing aspect of Eagle. Um, the next thing I'd like to talk about is this thing known as the autorouter. And maybe some of you have heard about it, but it essentially allows us to um, make all of these connections without the need of actually physically manually routing blank to blank, blank to blank, and such. So I'm just going to go ahead and run a little script line, and this is pretty useful if you need to rip up a lot of things all at once. It's just simply type in rip up, and it asks me, do you want to rip up all signals, and I'll say yes. And I'll go ahead and delete this little ground plane in the back. To use the auto router, you need to go to the bottom, and you'll see this option that says auto router. Go ahead and click on that. Now, it's very important to note that the auto router is not optimal if you don't know how to use it properly. And in later tutorials, we're going to cover how you can properly set the auto router up to get, the type of PCB traces that you actually want. But if I just let it, in my case, it has access to the top layer because it's in auto, and it has access to the bottom layer because it's also in auto. The effort correlates to how many variances it will give me. So variance is simply a different set of traces that it was able to make the same connections with. So if I select high, it's going to give me more variances versus low, where it's just going to give me probably 8 variances. Okay, and the top router is this special algorithm that allows us to it generally will create the most optimal routing variant compared to any of the other variants we look at. So if I hit continue and I hit start, you see it went through a couple of iterations, but this is what it came up with. Now, from what it came up with, so you see that at the top you have your top router, and that's generally going to be the algorithm that comes up with the least amount of vias, has the highest amount of completion. But if I look at these other variants, you can see that they vary slightly from each other, and you can select whichever one you want. And I'll hit end job, and if I look at what it came up with, it's not too far from what we had before. But kind of the auto router, because we didn't set up the auto router properly, it didn't make the traces as thick as we may need it. So depending on the actual trace width that it used, in our case, if I click on the I button and then I click on the trace, it says that it only used a trace width of about 6, which is probably fine for this application. But in some applications, if I have something that's going to pull a lot of current, I would really risk damaging that trace and burning it out completely. So that's something we're going to have to learn later on, is how to optimize the autorouter to get the best layout possible. Alright, the last thing we're going to cover, and that's sort of just our basic run through of the board layout, is our design rule check. So whenever you feel you are very confident in your layout and you're ready to send this to a board manufacturer, I highly recommend the first thing you do before you actually send them the file is to do this DRC. Alright, so this simply checks whether all of the parameters of this board are okay for the board house. Okay, so if I click on some of these options, you can see that there's a lot of different stuff in here that we could possibly change. And later on when we go do an actual design, I'll walk you through what each of these mean and how we should change them accordingly. But if I just go ahead and hit check, you can see in the bottom left it tells me that there's no errors. But let's say I go ahead and just delete one of these traces here, and now there's an air wire that exists, and I try to run this again, you'll see that it throws me an error. It says there are two air wires, if you didn't notice. And this is actually something that can happen pretty commonly when you have a large size board. You may see this tiny line. You may not be able to see that tiny line, but when you run the design rule check, you can actually see a bunch of stuff that you may have missed. All right, and that's pretty much the basics of how the board layout function works and how Eagle goes about routing and how you can go about laying down your components. In the later tutorials, we're going to take on a much more complicated layout and try to go through the process of how we do a layout on that. Okay, well, thanks for watching, and I'll see you in the next tutorial.